Recording in progress.
День добрый. Мы продолжаем, начинаем.
We continue.
Не успел сказать. Сергей Владимирович Сыра,
Sergei Stewart, Deputy Director and Chief Custodian of State Russian Museum. Dear colleagues, you know that in 2022-2024, we spoke about UV in the spectrum we use in the museum work. This is the topic not in the spotlight of all the people, but very interesting for restorators and researchers. This year, we decided to tell you about infrared spectrum, what's under the layers of painting. I'll keep referring to some of the slides. Maybe it will be about physics, but the standard spectrum, there is the small part which is visible. That's where we perceive all the information by our eye. Then there is X-ray and UV domain, very big infrared, microwaves, different ranges. We work in this ultra short range in infrared range, which is huge versus the visible one. Not everything is good for museum work, but is the closest and the medium infrared range. You can get lots of information for restoration and research. What is happening if the visible light goes on to the picture, getting through the layer of varnish and lacquer, but infrared gets through all the layers. It's like it's transparent paints. It goes all the way down to the ground where there is a drawing or something in the composition. You can see it on the monitor or in the camera screen. This is the property of infrared radiation, penetrating many pigments and absorption by carbon. It's a pencil for the preliminary drawing. That way, we can get a lot more information of different nature. Let's see what we can discern here. Classical infrared drawing, we can see what's under those painting layers. How certain small details are developed. Each and every painter is highly individual in what he is painting. When we get through all the layers of the painting, we can discern the author's search, and maybe the author was just hiding it from the eye of an onlooker because he was looking for different ways of composition. Under the layer of painting, you don't see normal what's under there. And the author thinks, okay, I will paint something, but nobody will see it, but we can see it. You can see the picture. These specials wanted to superimpose it over a new canvas, but then they decided to discern what's underneath. In the middle part, there is this inscription there, Conqueror, painter 1910, architect Rerich, the junior brother of Rerich. Is it important or not? That's important for art historians, so we can see the author's name, the confirmation of one of the relatives, the date. This is important. Hadn't we looked at this signature and recorded it, we would have lost it. Nobody would have ever seen it. Or maybe a couple hundred years after, people could see it if it would have been superimposed over the new canvas. Different types of pigments under the spectrum have got different degrees of absorption. Here it's the picture by Temeretsky, some inscriptions. Infrared shows us certain parts which we wouldn't see otherwise. Visually, the pigments look very close. They're purple both, but the composition is different. It was written later on. In the middle part, there are several semi-obliterated, semi-deleted lines with some letters. Let's see again in the left-hand side part. There are those lines of letters and words almost deleted. Restorators, before starting working with icons, they should do the preparatory work. You can see those blackboards. Under good illumination, you can see the plot. Otherwise, it's just the black board. And what's underneath this oil, if you the luminescence is the classical variant. Many think that UV will help to get the information, but it's not the way. You'll see the same dark thing, dark green color only, and infrared will show it, and those layers of oil and varnish will be transparent. You'll get information about the picture or the losses, where the author's inscription is there, where the painting is. Maybe you should not unclose this icon. Maybe there is nothing under this black oil. Installations of the Russian Museum, there was the restoration, the workshop of oil paintings. Before the restoration, one should assess the volume of restoration, develop the methods, how it will be done. Visually, the picture looks quite in a good condition. There are some dots again, the background, and the restorator says it's a very light restoration, but we decide to see more because there are certain parts in between the varnishes, the darker tones, alpha red shows those crates which are not discerned by the eye or luminescence due to a thick layer of yellow varnish. When you remove it, you'll see those huge holes. You'll have to get rid of them. So you should drift to another method. Same goes here. UV shows that something dark is out there, and you see in which place and which losses are there. In the picture, you can record them, and you should figure out how much time would be needed to restore it. How can we do the research? There are different cameras, photo cameras, filter and arrays, infrared scanning devices, architectural, wonderful thing. For 15 minutes, it scans the picture and provides for very good image in megapixels. Lots of other cameras are out there which are used for safety and security purposes, protection purposes, military purposes. As to infrared spectrum, most of the users of infrared arrays and cameras are for military purposes, up to 99%. It's dual use military goods, so it's very difficult to import such cameras into our country, especially after 2022. All the American and German and other manufacturers and suppliers cannot do it any longer. So we can use conventional photo camera in laboratory. Its array matrix is created, and you pay less than 100,000 rubles to get this camera working in this range. But there are pros and cons about it. Classical variant of silicon arrays in this range is 1,000 nanometers. The closer range, it's only 5 or 6% of registration is lost. Infrared range starts from 750 and 800. It's 5, 6 10 microns. So using this camera, we'll see only the very edge of infrared spectrum. It's not by far enough. Oftentimes, that's the conventional variant of different arrays and matrices in photo cameras. They work all the way down to that micron. So they get only a small chunk of the spectrum. Is it good or bad? It's good because you see at least something, bad because you don't see most of the information which is hidden under those layers. But there is a way out of the situation. There is very specific matrix and array working in different range, so we can see much deeper devices on the basis of these arrays are referred to dual-use goods, but nonetheless they're available in the market. The major type of the detector is the array per se. Mostly all the arrays which are available have got 240 to 340 the resolution, which is not very high. You can see the picture, but to discern what's under the painted layers and print out it and use it further on, this is not enough. But for aiming the missiles, that would be enough. It would be good to use those subsystems, different other filters and arrays. They cover the further range of the infrared. A camera with a filter will not provide you with lots of information. You should use something more sophisticated. We should figure out what we should opt for. A very cheap variant working in infrared range. This and scanning camera, which could be imported via several countries, but that will take an awful lot of time and it will be awfully expensive. Or just other types of the cameras which are available with sale, but the resolution is not very high. Just by way of an example, this is the item in the museum. It's an old canvas by different pigments. We've written different inscriptions and we put brown ochre over it. And we started experimenting with different cameras and photo cameras. This is the photo camera with the middle filter. We can see that something is there somewhere under those brown spots. Something shows on as white or black letters, depending on the color of the pigment, green or red or navy blue. When we get onto deeper region, using more sophisticated camera, we get this variant. We don't see the brown pigment hiding the inscriptions. We see parts of those inscriptions in a good way. It's a good contrast. It's another variant, another level. We should not bother about the upper layers because we can see through them. Let's take this picture, for example, under the landscape. We can see, I think it's a dog, little dog lying there with paws crossed with thought that maybe the painter first painted the dog, then the landscape on top of it. As we get to a deeper domain, we can see that under the dog or under the horse, there is a suprematic composition which was not to be discerned when we use photo camera, and the landscape, which we can see above in the picture, it disappeared, it vanished. We can see the horizon line and nothing else. So we penetrated all the way down to the ground, to the layer, to third layer even. But when there are thick layers, oftentimes several layers, oftentimes it's oil pigments, so it's very difficult to discern the hand of the initial icon painter because not all the icon painters were putting their signatures under the icon. It's considered that each and every pattern is very individual, and painters not always think that the people would see what they first put on the icon. This is one of the icons from the icon stand. background of the ancient monastery. Specialists think that they use the icons which were created by several icon painters, but how to divide and discern them? Try to do it based on the pigments. They thought that each and every icon painter is using their own pigments. It was not the way it was, or they looked at the folds of the apparels, but many icons had been through the restoration beginning from 15th century and repeatedly. It's not quite correct. When they looked at the patterns and drawings, it's more interesting. Using conventional photo camera, we can see those inscriptions as well, and it seems to us that we reached that initial drawing and painting created by the master, but you should get much deeper. This is the real painting. The icon painter sketched the face of a saint, very small one, so you can attribute that I can do this or that icon painter. A photo camera shows something, but it's difficult to figure out what's in the visible domain, what's in infrared one. This is a very good brush painting which refers us to specific icon painter. In conclusion, when we mention those devices, how should we get this infrared spectrum? Any source of heat would be a wonderful source of infrared radiation. Lamps, spotlights, contemporary LEDs, lighting fixtures available in the market, but they have got some shortcomings. They are created for specific camera, customized. They work in a specific and limited range of radiation. Many say that LED lighting fixtures are rather inferior because they are like spotlights, small ones. They do not illuminate the big canvas, but I wouldn't agree because even large canvases could be lit up when there are those LED lighting fixtures. One source of light is enough to have a good infrared image, but it's best to use conventional camera, very cheap one. It's in the contour and it works in all the range, invisible, in far, and in the middle one. So those small LED fixtures are good. But as to cameras, in Russian Museum they use it. This is available in the market. It's Sony cameras. Nonetheless, they have got a very good resolution. No aberrations on the edges. There are lots of infrared lenses, broad angled and others, and you get the same picture. You don't have to wait for scanning time of 15 minutes. And you get the image you are willing to get. You can see what's underneath. On top of that, it could be used in the laboratory, in the exhibition. And you can bring them over to the exhibition, let's say Minsk Art Museum, or you can work in stock repository or in the churches where there is only one socket for plugs. It's a very small portable camera. You can put it into your pocket and you can work across the entire infrared range. As to all the pros and cons and advantages and disadvantages of using that is not possible within 15 or 20 minutes. We have got a big database of different images. We have got training sessions written for that as well, and different presentations. 2 years after the next conference, I'll be privileged to tell about all those interesting studies.
It is very important for all the colleagues of ours. Thank you for your attention. Well, thank you. Are there questions? Yes, you're welcome. You're welcome with your questions, right? Use the microphone, please. I have 2 questions. No, it's not difficult to have a computer model of all the layers of paint. Well, of course, this means that we have to work with the computer a lot, but in order to define the range, we really it's enough to work with the edge. No, AI in this sense is not being used. We're using AI, but for different purposes, for the database, for the museum paintings. That's where we use AI and machine vision. Yep. The ratio, the luminance ratio, yes, that's very good. And we can actually analyze the pigments on the painting and we can try to synthesize it. But what is the problem here? The present-day pigments can help us achieve exactly the same result, and visually you won't see the difference, or you will see it if you examine the specific properties. If we combine calculations, experiment, what kind of a result can we get? No. Now, that's an option, of course, but that's an option when the purpose does not justify the resources put in. You are carrying out the work for the historians, for the restorers. So it's the work actually done for the sake of science, science for the sake of science. No, the microphone is not being used by the person asking questions. Okay. No, from 200 micrometers terahertz range is being used. Yes, we worked with that. You remember the test artifact? Yes, that's exactly the example, and we had very interesting results. This is a multi-layer painting of the 19th century. It's from a private collection. On the other side, on the reverse side, there was another painting with the grounding, with the whitewash, and from the reverse layers, we were able to see what there was under those squares. So we were able to look at it with the help of terahertz, but we also tried to use the X-ray. No, it doesn't work. Even the squares are not visible there because it's ultra-late material and it's transparent for X-ray. No, terahertz cameras do work. The English suggested in 2022 that we use them. Unfortunately, there was no way to get them. No. No, they are being used at the airport quite actively, yes, right. But as for the good scanner that would work for the needs of the painters and restorers, I haven't been able to see one yet. We tried to work on one, but the working prototype you might have in a museum to look at the frescoes doesn't work, yeah. Come to us, we might help. Yes, thank you very much. There are some positive things, but also negative ones. The Japanese have a manual scanner. I haven't seen it yet, but I hope that over the next 10 years, this technology gets spread extensively. Contrary to X-ray, it makes it possible to work with each layer rather than with a pie, and will help us resolve the problem of frescoes, as it's, just to try to use X-ray on the domes, for example, to understand the layers of the fresco, and you'll get just iron frescoes and bricks. So that's the task for the terahertz technology. Thank you. Any other questions? No, thank you very much. Thank you. Right, our next speaker is Natalia Abukhova, Doctor of Technical Science, Dean of the Faculty of Radio Engineering and Telecommunications of LETI. Good afternoon, colleagues. I would like to acquaint you with the results of the work carried out at university of ours. These can be useful for the museum and archives practice. And my presentation, in a way, is going to supplement what Sergei Vladimirovich has just said. He spoke about the infrared range, assisting us with seeing what is there hidden under the layers. And I would like to speak about how we can restore what used to be on the surface and almost disappeared with time. Now, the basis of the approach that is suggested are the multispectral and hyperspectral data. I will speak about the principle that is in the basis of the system, with the help of which we carried out the research and the study of the historical artifacts and the historical documents. And I also demonstrate results which were obtained as a result of our work. Here they are listed in the slide. We worked with the History Institute of Russian Academy, Russian State Academy, National Academy, and with the Research Movement of Russia. So what is multispectral and hyperspectral data? Now, the idea that is being used with that type of analysis of visual information is as follows. You all have mobile phones, and there you have a camera, and in the camera, 3 channels, red, green, and blue. On top of the slide, you can see the curves that comply with the vision of human eye, and any camera tries to reproduce that and repeat that. The colored picture is formed following the 3 upper curves. So you can see these are wide bills, in fact. So all the information that we get on the eye retina or on the matrix of the camera that has 3 channels like that, red, green, and blue, is averaging lots of things. So the nuances of the reflected light seen by us rather poorly. And so the idea of hyperspectral analysis is in the increase of the sensitivity in each of the channels. So instead of 3 wide humps, it's better to have many narrow ones. So the reflected light, which is on the sensor, is fixing a certain average, not an averaged response, but the response complying with the wavelength. So if RGB sensor has 3 coordinates, red, green, blue, the hyperspectral sensor forms 200 coordinates. And through the visible range of 5 nanometers, so you will have, instead of 3 pictures, red, blue, and green, but 200 of those. And scientifically speaking, actually in every point, in every dot of the image, we will have the spectral response, which expands the volume of information. Now, indeed, at the pyramid in the center of the slide, you can see how the volume of information grows depending on the type of the sensor. So if it's just the gradation of gray, we can see just the change of the luminosity. The RGB sensor traditionally has 3 coordinates. Multispectral, as it is believed, is the sensor that breaks the range into about 20 subspheres. It's multispectral, and in this case, we can see the approximation. We can build approximation of the spectral response. And in case of hyperspectral story, we get, well, our camera turns into a spectrometer, but it's not a point-like spectrometry, but it's a set of images where each layer complies with the response in a particular narrow spectral range. So the hyperspectral analysis can be carried out for different spectral ranges. And today we have already discussed that. We said that we are used to work at the near visible range from 380 to 760, 780 nanometers. That's the limit of the visible range. And then the infrared comes. And so this particular division into sub-ranges can be also used for the visible range, for ultraviolet, and for the infrared, both close and distant. And now, further on, there is another question, how to form the hyperspectral image. And here, in the basis of our complex, there is a scanning principle. So the very item is static. The artifact is static. There is an old document on the table, as you can see here. And there is the illumination. For our experiments, we used white light and halogen lamps with the color temperature 5000 Kelvin, and also for the pollution, and we used the ultraviolet range. Now, in the camera itself, there is a dividing optical system which divides the flow into different ranges, and the metric sensors for each line is a separate spectral line. And as for the movement of this artifact allows us to restore the shot. So this large volume of information is obtained within the framework of hyperspectral analysis, and it's much larger than with RGB. So it makes it possible to resolve a number of problems, and we focus our efforts on the visualization of the fading texts, including reading of palimpsests, so division of the layers, and the use of the ultraviolet light enables us to carry out the microbiological pollution, or contamination rather. And here you can see the order of work, and some examples that demonstrate how spectral information works. It's much more volume. The volume is greater. There is an example of an archives document. That's what the camera sees in the white light. So there is practically no color. It's almost completely faded, and it's not under layers at all. All these pigments, the reflection in the white color, white light, and so there is no proper response either for the camera or for the eye. So down below you can see the restored image, restored on the basis of the hyperspectral information. So here we applied a rather traditional for the hyperspectral information approach. We used the method of the main components with further visualization of the obtained components using the method nonlinear contrasting. And the principle I tried to present to you, and here are some of the results we were able to get. Now, we presented the results of our work were demonstrated at the exhibition Russian Industrialist, and we tested results together with a number of different organizations. There's a lot of different documents scanned, restored for the Archives Committee of the city of St. Petersburg for the documents that are under their responsibility. So we work with the Archives Committee of Tatarstan. Moreover, the Russian State Library and the Institute of History of the Russian Academy of Science are also among the partners of ours. So here you can see the research of the palimpsests carried out for the Institute of History. And of course, the idea was in the following: how to restore the text, lost text, the washed off, the text that is invisible, the text that gives the minimal response in all the ranges, because it was actually almost completely destroyed. So the use of hyperspectral technology makes it possible to fix those limited remains of the text, because there is no aberration of averaging. So here are the examples of palimpsests. With the red color, I demonstrated here what we can see in the white light, but what emerged as the result of the processing. And here are some other examples. Here in this document, you can see that on the left-hand side, there is a line, the invisible line originally, and the same is true for sample 211. So this was all carried out under the white line at the Institute of History. We had 13 documents from the Institute, 13 palimpsests. And the purpose was to see what used to be on the layer destroyed. almost completely destroyed. And so we were able to uncover the text for 7 documents. And so it's practically 50% of the research work carried out. Now, the next example is associated with the manuscripts from the collection of the Russian State Library. And here, strictly speaking, we were to analyze the hidden text or to make it possible to read the texts that almost gone. So you can see that we can see the result of a previous examination of these texts. And when we talk about this collection of documents, initially a very large volume of the text was absolutely not readable. And after the hyperspectral analysis, the text can be almost completely visible read. The examples here are different pages of the text. On top, there is the original text. That's what we began to work with. And down below, you can see 2 examples, the components of the hyperspectral analysis carried out. So you can see they are obtained on the basis of a spectral cube. And some other examples, how is it possible to make the text readable? So again, a document, the original document is in the center, and what was reconstructed, you can see on the left and right-hand side. Another example from the collection of manuscripts of the library, the Gospel. Once again, here is the result that is quite positive. After the analysis, we're able to read the end part of the recording, which previously had not been visible at all. Again, the Gospel on the right, on the right and left-hand side, you can see the original. So on the left-hand side, the original text and the rebuilt or reconstructed text. And we can see that almost everything is readable except for some letters. So there is a larger volume of information as a result, even in the old documents, like the document of the 12th century. With the help of the suggested technology, it works. So here are some other documents that were previously there were attempts to restore the document, and then after the analysis, the volume of the text increased. No, and then some archive documents. These are probably even more effective results in a way. This is the work done for the St. Petersburg Committee for Archives. And here we were actually tackling the same issue, restoration on the basis of hyperspectral analysis. And here are the examples. The original text, which is not readable at all, and respectively, since we actually were able to get many more responses, and so splashes, so to speak, in each and every spectral channel, information channel. So the text becomes visible, and not just visible, but actually the text is readable, easy to read, in fact. And another example, allow me to say that there are different types of pigments used for the original texts, but with the hyperspectral analysis, these pigments can also be classified. So it's not only the source necessary for the restoration of the document, but it's also a possibility of carrying out the work of the artificial intelligence, helping us to identify the pigments which were used for the document and for the text. Another example. Well, they're all similar to each other, in fact. So you can see that it's the documents are of the middle and the end of the 20th century.
They were stored at the Central State Archive. I'm here to say that this approach allows us not just to restore the text information, but by the same token, some images of the prints, which is not seen in the white light, but otherwise it could be seen different components respond to different spectral ranges, and there is different information from the documents is present here, which guarantees the completeness of restoration of information, and that way we can classify this information. Some other examples are here. You can see the inscriptions, seals, and prints which were previously lost. A very interesting result which obtained is the restoration of the drawings and layouts of Sestroretsk Spa. They are stored at Central City Archive. They were made on the material which, according to the authors, would guarantee very high degree of preservation, but it was just the reverse. The most of the drawings fully disappeared, together with the care and traditional ways to get information from those lost drawings fell flat. No results at all. And what you see on the slide now, it's the restoration on the basis of hyperspectral of the drawings of Sestroretsk Spa. That information which seemed to be fully lost is restored here, and the images could be formed in a good resolution, so it could be scaled up for further analysis and for inventory purposes as well. On top of that, this technology was applied by us to analyze soldiers' medallions, which were provided for us by the NGO Movement Association called Russia. And when we used that is a spectral approach, we could restore the information about the soldiers falling in the battlefields. Microbiological analysis also could be used here in white light with a reflection, a division of reflected signal into different ranges, and also in UV spectrum. We formed a unique database on all the archives of St. Petersburg. We did the research, which was reconfirmed by biological sampling and testing for certain fragments, which we studied. Let's say they have demonstrated some changes, or there was no visual manifestation, but we did the sampling in a biological way. That way we formed the unique database on the basis of this approach, once again. So that further on we could put together a map of different pathologies. On this slide, you can see different characteristics which prove the exactness of classifications on pathological and non-pathological sites. If we see any contamination, we can see that even if human eye doesn't see it in the first place, because oftentimes all the documents have got different parts, some part which has got a dark spot. It's not always biological contamination. It could be some moisture or whatever, drop of moisture. So there could be operative control, which is very helpful for our approach. We applied it quite successfully to identify the degree of hazard of this document. Maybe it should not be kept among other documents, and before we should do the special cleaning treatment of it. And that about wraps it up. I'll take your questions, if any. Thank you very much. My apologies. I didn't present the co-speaker, the special chief engineer on the storage. Hyperspectrum is good, but it's not correct for the reverse problem. Because you should extract more information. And you are resolving certain tasks less when you can treat the certain old documents, but it's not a one-fit-all remedy for all. And you said it's about 200 lines. 200 lines. It could be only used by neural network. First of all, as to regularization, it envisages the situation when you know about all the regional regularization by Tikhonov. I was talking about something else. I said that the use of the system which would enable to detect the feedback with high sensitivity is good. The enhancement of spatial resolution provides us with more information. More information increases the spectrum resolution. We should not forget but that any chromatic coordinate is an integral of the range of the sum of three spectrum, the reflected spectrum to the object and illumination, the integral whereby three functions are multiplied when we identify the spectrum sensitivity, which would impact the amount of lost information or just averaged information, but that's a judgment call, of course. As to the noises, they're always around. But those components we have been using enable us to correlate this space of different attributes and to identify the most important information. So as to the noises, it's not always that bad. As to AI, of course, AI restores the information without any doubt, but it thinks about it. Generative AI forms the picture, but those neural networks form it on the basis of what they had seen before, and it's common knowledge that there could the second hand appeared or something like that. In medicine, they never ever bring up the issue of just regeneration of the images. You'll never guarantee the correctness of this image. It's possible to use if you're going to make flowers or something, to use AI for generation. It's quite misleading for researchers when you're going to use it for classification. Contaminated or non-contaminated document is good. A small set of data brought about the situation when it's not very deep learning. Thank you very much. Natalia, thank you. Raise your hands, those who understood the essence of the first question asked. Thank you. I think you should discuss it on one-on-one on the sidelines of the conference, because 90% of people didn't even understand the subject of your dispute. Thank you. You can discuss it one-on-one. On the sidelines of the conference, I reiterate, next presentation. Vladimir Hudak, professor of chair of lighting fixtures. I'll explain first. I was supposed to speak tomorrow and speak about standardization and so on, but it so happened that I have to leave today and be in other place tomorrow. So my presentation was transferred from tomorrow's into this day, and I'll speak about the technology of lighting and different techniques. As to certification and standardization, of course, it's the confirmation of a standard. Standards are not changing, and after a while, we all find out that this device may not be fully in compliance with the previous standards. Maybe but I am engaged in digital models mostly in my everyday chores, and digital models could be used to certification. It's digital twin. It's the variant which would help us to trace our standardization in a very dynamic way. What's important for a museum? Museums are using more and more operable and remotely operated LEDs. They are controlled. So we are all aware of IoT, Internet of Things, and other things, so we can keep track of each and every lighting fixture also. And we are speaking about sometimes change of the rules of certification in Germany. They have this used to have this concept. The light should be there in the amounts which are needed for certain premises and museums, of course, and we should put it all in conformity. And so all those parameters of LEDs could be adjusted for future. This is about the digital passport, which is a very leading trend in EU countries, and we should make a mental note of that as well. And of course, we could be able to validate it via the network. Let's say we're going to shift to a new type of certification. We should also validate all those networks. And also, there could be vulnerability in the network. It's all about cybersecurity. Very big funds are channeled into that. What we're talking about, Internet of Things, digital twins, and so on. Cyber vulnerability is out there. Cybersecurity is there. So we may create different digital analogs, and what we're dealing with, illumination, it's there for UV. Can we guarantee on the basis of digital model that it would really work in practice in the museum? A digital twin of a lighting fixture. This is that important part, which consists of thermal and electrical part and a set of technical parameters and different network parameters so that this digital twin could be useful for our purposes to validate the system when we create first the model, the simulation. There are three levels for digital lighting fixture. We can connect this system to one lighting fixture or to different lighting fixture or group of lighting fixture. And first we do the simulation models. So digital twin is out there for us to help test different combinations of lighting fixture, light temperature, certification according to the digital passport. And this system can detect all the deviations from the standard condition. And we can test and validate all the lighting fixtures in one batchment. Adaptive, adjusted illumination is very important for the museums. I was impressed by the previous presentations about light and the method of validation. It's very important to optimize the observation for the museum because we should find out the common features, the affinity between different systems of lighting. When visitors come to the museum, it should be comfortable for them. And there is another issue here. Contemporary painters can articulate their own conditions and requests for the conditions and degree of illumination in the museum or in the exhibition. Contemporary models of visual perception, CCCAM, other types. And so the previous conference, the model SECAM 16 was presented by the president of it. So it's very good visual perceptions by the viewer. But there could be different sensations and different characteristics. That's what modern painter wants from the visual impact. But in real life, we can find other perspectives, light installations. This is very promising when we can unite paintings and installations all together. That unravels new opportunities for us. This is a new trend for lighting fixtures, light exhibitions. So painters might request different conditions for lighting, but there might be some contradictions between physics as science and art as well. But physics as science could help the artistic endeavors in contemporary times. The other day, there were heated discussions about exhibitions. If there is a digital model, digital twin, we can make predictions so that we would exactly know which painting at the exhibition should be placed where.
And certain recommendations for the museum community. No, I think this, I hope you support me. It's necessary to develop the digital certification, as these are all the requirements that are necessary for all of us. And it's necessary, I think it's important indeed, if we have a commission that works on the adaptation of the standards to digital realities. Then it is also useful if we start all the work with the individual groups of light fixtures, testing them, and then spreading the experience over. Certification does not disappear, but it turns from the stamp in a passport into a never-ending digital process. And it also seems to me that all those museums who follow this particular trend, they will become the leaders in the sphere of protection of the cultural heritage. And a physical light fixture, as examples from the Hermitage, we can actually use the twin and examine the physical characteristics with details. And it's quite possible to do that. It will be also to predict what might happen to this particular artifact with time. And this also allows us to fix changes that might occur. So last, it's a light as a service. So I think it's a very interesting phenomenon, as much light as we need. Auditing and design work, and that's all very important. It's good to say that all this is happening, but who is going to carry out all this work? Providers, I believe. Installation of equipment, also providers, but then as for the definition of the parameters, the customer does that, and the monthly pay. Now, well, of course, that's very important, and these things are very often come together. This is important for the customer, for the provider, and if something disappears, then the customer can claim the damages. And now, if time permits, allow me to raise certain questions we might discuss now. So, if the device is outdated and the certification still works, what do we do about that? And then, neural network, can it replace humans entirely? Well, there will be humans in the museum, so there will be just neural networks functioning. And this digital twin, will it help us to understand who is right and who is wrong? I think this is all resolvable, but it all can be discussed. And yes, I mentioned that already. Then Van Gogh was able to sell just one painting during his life, and well, could he possibly sell two had there been different conditions? And finally, all the visitors are very different, and if we try to satisfy every single one, then it's not going to work. No, what do we do about that? Now, if time permits, we can discuss that, although I really do not know the answer to that particular question. And finally, allow me to quote Einstein, out of clutter, find simplicity. Yeah. Well, thank you, Vadim Pavlovich. Any questions to the speaker? Yes, you're welcome. Lots and lots of questions. You mentioned ZCAM 16, a model. And please notice the articles, the fresh articles that most probably they're actually removing that and they're moving towards KLM. So this is going to be a revision, and I'm afraid that many of the specialists of ours are going to stay within the standards that are going to be revised. Yes, let's look at how NCAO works. NCAO is not inventing everything. They are just standardizing the work carried out over the past 5 years, like ZCAM 2 years ago. Yes, and every so, well, of course, the scientific publications do exist, and the standards lag behind. A standard is something that is recommended and tested. Well, thank you. Other questions? Right, yes. I have a comment rather than a question. You're introducing new expenses with the new innovations, and the museums living on budget are unable to carry out this burden. I try to analyze that. Yes, I'm not a lawyer, of course, but yes, but Yes, I understand. Yes, and even suggested some solutions. I'm not going to maintain that I'm absolutely right. No, that's not what I'm saying. Other questions? Yes, Световые технологии. Yesterday, Lyubov Volgina spoke and from the Terekov Gallery, and she said that they carried out the work and illuminated several halls, and they work in the paradigm that is described by Dim Pavlovich with continuous monitoring and correcting and amending the changes, the following the changes that are necessary in the process. No, I would like to say that in this sense, digital factor is not needed. If we have a provider, as you say, someone responsible for the work, then it's quite possible to work within that particular mode. It's possible in today. If you understand your question correctly, the digital twin is needed for forecasting. It's because it can forecast what might happen. That's a question. We can have the light that we need, and as much as we need, we can interfere and we can create the conditions for observation that we actually need. A digital twin is a very important component, I would say. I missed that presentation from the Tikov Gallery, but I think the digital twin is a very important element. So it's a model of the behavior of the light fixture in the process. Yes. So when we acquire a device from a responsible manufacturer, you get guarantees on that particular type of the behavior of the light. It doesn't mean that you get something unknown to you. No. But let me say that we're not just checking. It's an integrated approach. Digital twin. Life it happens. I worked on digital twins in the northern seas, together with the ocean studies carried out at the time. And with the lighting fixtures, I think this technology might work, and it's quite attractive. So I decided to try it out. Now we can see that there are expenses that are somewhat higher there on the seas, on the satellites. There are vessels of different types and lots sorts of things. So the digital twin is a very strong instrument, and it helps a lot in that research work over there. And I think this similar approach is very good for the lighting. Because Vladimir Pavlovich, thank you very much for your presentation. Thank you for the digital twins theme raised. And when you spoke about the new types of certification at the time of digital technologies, you said that an artist, an author, or an art historian can and should define the conditions of monitoring for an artifact. And I think that's a peculiar matter, because let's say there is a new film, a new book. Of course, the author invests a lot in that, but that's interesting indeed, that the viewer or the reader reads something for himself or herself, and that's why that particular work lives. Don't you think that if we have certain requirements, certain wishes clearly explained by the author, then that will mean that the curator, that the light designer will be restricted in their work, because it's always interesting to be able to see a painting under a different type of light, to understand what it looks like, what it might give us. Maybe this. Now, first of all, I'm not categorical. No, I said it was possible, not should be done, but it's possible. Now, once half a year, I visit the Emirates, and in Abu Dhabi, there is a lot of light design and installations. It's very interesting. You approach, there you are in the desert, and there is no place for parking. There's so many people to visit. So it's the form of art that is extremely interesting. We cannot ban it. So if the artist formulates some conditions of lighting, then why not accept them? you remember I remember a showroom actually with museum light, and so it's a museum light, and so there's a mobile software used there to control the color temperature, and there in the painting you can see a twig. You can find vine actually, as if you were in the vineyard. And so nothing should be banned. And we're not insisting on anything at all. No, we're just suggesting things. Yes. Thank you. Anything else? Any other questions? No. That's it. Yes. Thank you very much. Thank you. Thank you. Right. I would like to say that, well, of course, it's my opinion concerning the digital twin. Well, of course, that we should aim at it, but we understand we are very limited in resources. We do not have money for bread, not only for cakes, and so. But there's something to develop. That goes without saying. Our next presentation is the control and management of the museum light from design work to realization. The IEC Digital Company. IEC. Well, right. Oh, yeah. Yes, you're welcome. Good afternoon, everybody. Our company Digital. Digital company is making a presentation, and I will speak about automation and control of the museum light and the Internet of Things, the Ambient trademark. Quite often, we have to deal with different measures with the correct lighting of artifacts. So we think of how to preserve properly the artifacts. We know that the light can have a very negative effect on that, on the conservation process. It can damage different artifacts. Now, it's also important to think about the visualization, about the perception by the visitors, and technically all this needs to be carried out. So when coming across this particular problem, remembering that very often different systems are used for monitoring, for control. So the work is disintegrated. Sometimes there is no automation involved. It's all manual. So no scenario. So there is no uniform system. This brings about extra problems. So we would like to speak about the potential use of the comprehensive approach, where all the scenarios, in spite of the protocols for lighting, with logics integration, pulled into a single system, into one manageable platform. And that's what we're planning to suggest on the basis of the resources we have. Now, in the architecture, it's very important to allow me to speak about the proper use, as we think, in the museum lighting of several protocols. We know quite well that each and every one of the protocols, the LEED, MAX, ArtNet, and others, they all have their own functionality. And each of them is applicable in a particular case of the light automation, depending on the goal set. But very often all this work is disintegrated. As we said, we suggest, where possible, the combination of this work following the DALI protocol, DMS protocol, the scaling through the use of ArtNet, and all this through a single system of software. In a bit more details, DALI always provides us an address, stability, and statics. But unfortunately, DALI does not give us the adequate response. It's not as quick as with DMX, and DALI helps us to sustain the work, and the regimens selected makes it possible to work with the sensors, to have the proper journals and recording. We control mistakes and faults, but DALI, as I said, lacks the response speed to the signals. And the DALI Well, of course, depends very much on the properly selected light fixtures, the brain, so to speak, and the modules of expansion. These make it possible to connect quite a lot of devices when we lose just one central controller. DMX makes it possible to provide high speed of response when we are talking about the architectural illumination of the facades and museum buildings. Dynamics is very important. DMX ensures exactly that, and so that means it's possible to change the colors quickly. So what is the difference DMX and ArtNet? DMX allows us to ensure the speed, but unfortunately the targeting is limited. DMX makes it possible to work with up to 12 devices, and some complex strobes there might have 24 of those, and so necessary to increase the number of the universes that can be connected to the system in order to have a large-scale museum projects implemented. And so scaling is very important for us, and the ArtNet can help us with that. ArtNet system actually scales DMX to the necessary level. Our principle is not to invent something absolutely new, 3-in-1, but depending on the situation, depending on the terms of reference and practical conditions on the site, to suggest the use of 3 systems simultaneously. DALI providing specificity, DMX dynamics, and ArtNet scaling, the increased number of the devices connected. And all this within software through one control system. And here in this slide, you can see how this system, the DALI system works. You can see the commutators, the controllers, the light fixtures, and all the extra appliances. And you can see how it works. It's all demonstrated here in the slide. Of importance here is design work. And when we talk about design work, we very often consider lighting, of course, but unfortunately we forget the controlling functions. And as a result, at the stage of implementation, we might come across certain problems. So at the stage of design work, it's necessary to remember that the right lighting and illumination can be achieved through the use of the proper controlling systems. And so this should be embedded into the projects at the level of the design work and the original documents concerning the project. And the properly selected equipment makes it possible in the future to carry out different scenarios, zoning, limitations on luxes, and that's all very important in the museum lighting, depending on the artifacts, because the system of control makes it possible to dim the light if necessary, for example, and even when one and the same artifact we would like to see with different types of lighting through the dimming or the increase of the light intensity, we can have a look at the artifacts at different angles, and thus we can achieve different levels of perception. And the selection of equipment and compatibility are very important here. These are critical factors. It's important to select the proper light fixtures and the representatives of the well-known respected brands are present here today. They all understand that it's important to start with that. A device should be high quality and controllable. So in order to organize the control work at the proper level, we need to select the proper equipment and drivers, among others. Controllers should be also selected properly. Further on, we are ready to manufacture, we're ready to carry out integration. And integration is possible with the focus of the work with the use of different scenarios. Moreover, the previous speaker said that certification requires Apex to be used. Now, we have a system that is open for integration with different manufacturers of software.
So we provide the access via API, and if there are some other manufacturers' equipment installed, we're always open to provide you with this access. Aside the lighting and illumination, we're already willing to scale this up via IoT, Internet of Things, and other things, other objects, or it could be as well as a different functionality of IoT, which we're ready to scale up. And also, I would like to add that we are ready to create different software scenarios. They are developed on our platform already. There could be scenarios on temporal slots, biodynamic control. Let's see if lighting fixture allows to do that. And also, aside this, on top of everything, in case of necessity, we are ready to provide for extra ancillary functionality depending on customized request, a different object. For us, in everything we do, most important thing is the deliverable, the final outcome. It should all work and give you pleasure, make all the sides happy. The museum workers, custodians, lighting fixture manufacturers, visitors, and we can get the feedback programs of reports, debriefing of the situation. It's possible to use different gauges and sensors of presence and so on, and different parameters of light load, which is very important as well. As to the facades, architectural illumination and landscape illumination provides us with a broad range of different scenarios using inner light, and the control via ArtNet will enable you to come up with high scale, big time projects for you to realize all your tests. Several more words about the platform. Our platform is enabling for making very good and high quality control over light, and also to get the analytical information, to do the research, to receive different reports, and we can provide the certain limits of the access to different work, because you'll see the energy efficiency as well through those reports. And what's very important is this: if the system of alerts, if this or that fixture fails, this is a system of alarms, and the operator would know exactly what's wrong, where it's wrong, which one of those lighting fixture devices is out of order. Everything is there in our software, and there is the function of imaging and visualization. If this or that specific lighting fixture is located in this or that hall, it can be tracked down very rapidly, and it could be fixed in a rapid way. This is the economy of costs and energy efficiency as well. And also it's about cutting operational costs. The beauty of it for the museum is a high quality exhibition. We know how we can control light in the right way, and controlling light, we can reduce or just the reverse increase the light flux to be in conformity with all the necessary conditions for artifact for visitors. It's very pleasant and comfortable. Visualization is everything goes right, and cutting costs drastically, which is very important. Payback period is at the average between 2 and 5 years, depends on the artifacts and their complexity. And bottom line idea we would like to convey to you, we offer light as a general controllable system with different decisions which can be scaled up. And key factor is that they are all united in one system. It's very simple to control, and thus we can cut costs. One more thing before I finish up. Several words about the company, what we do in most part. We are the developers of software. We have got our own software, our own team of software engineers and developers. We also manufacture Russian equipment, control devices, gauges and sensors. It's all Russian manufactured. And also design. We have got model standard solutions for designers, and very important process is pre-commissioning work we do on our own account. The integrated comprehensive approach is very helpful for us to implement our main task, which is the right light, which is controllable and scalable. Thank you. Are there any questions? Go ahead, grab the mic. Have you got any benefits, any discounts for museums? The system is really cool. It's impressive, but it's expensive. It depends on artifact, on the sites. We can offer different solutions. Everything can be tailor-made. We can offer you quite an economic and much cheaper solution for a small artifacts for small sites, one intelligent cabinet for control is enough for that. But it's economically efficient and easiness in operations. Thank you, I've got it. Anything else? Thank you so much once again. Next presentation, Natalia Kezina, CEO of SOART Joint Stock Company. Invisible orchestration, how light sets the route for this viewer, and what's more important, the object or how we look at it? So the microphone is on. It's okay. Good afternoon, dear colleagues. I appreciate having been invited and introduced. Now, my presentation is not going to be highly technical, but I would like to share our experience in creation of the exhibitions. For a long time, the word lighting at the museum was synonymous to the word protection of safety of the objects. But now museums are not just repositories, they are turned into the space for communications, and it's very important for us to manage the attention of the viewers. Well, when was it the last time you visited the museum? Which exhibition? St. Petersburg is the city of museums and exhibitions. And how long did you stay for each artifact at maximum? How long did you stay at one artifact? Not just take a picture of it, but look at it. Do you see what other viewers are doing? What did I see looking at the visitors? It seems to me as people are walking around the museum without making a stop, just making pictures, recording the fact that they entered the museum, see the museum's vibe, took pictures, and all they go. Digitalization impacts our perceptions of art. People are just using gadgets and images to manage information. Vivid verb information, animated information is elsewhere, and that surplus of images is not so good. So we museum workers should help visitors to make a stop and to communicate with the artifact, to think about it, and very important partner of ours, the key element. Our lie here should be light in the museum, supporting concentration and attention of visitors is sometimes difficult when there are historical buildings or some limited, restricted areas whereby the spaces are not meant for the exhibition initially. So we could help the organizers of the exhibition to make light playing into their hands to retain the attention and concentration of visitors. So that was our project, the creation of memorial exhibition, the Hermitage amid World War II. We developed the concept and the project all the way through, starting from selection of equipment and artifacts, and we engaged all the departments, operational department, fire extinguishing department, and all the others as well. The space selected for the exhibition is unique in itself. It's the underground space of the Hermitage, whereby the military anti-bomb shelter was located during the Second World War. So it was a challenging task because the basement is full of different communications. But the exhibition means multimedia installations, archive documents, siege documents, and a very complex scenario. The topic of the siege of Leningrad amid the war is very important. There are lots of different narratives, but it was very important to strike the balance between history and the humanity. The exhibition goes gradually, consists of 6 parts. First, the evacuation of the Hermitage collection, when first it was sent to Sverdlov, secondly, placed in the bomb shelter. That's where that collection was. And then the sky of besieged city of St. Petersburg, and all that anxiety and alarms going off, then the return of the exhibition after 1945. It was very important to lead the visitors all the way through that history without losing the depths and the sentiments and emotions. Before we embarked upon the technical part of the project, we started out from the visitors' route? How do they enter? What springs to their attention in the first place? Where do they hold their gaze at, and so on. So for us, it was most important. It was like a light thread underpinning the entire space and uniting it. This is a 3D lighting fixture, a tube located in the cylinder, high degree of IP protection. We developed special paddings on this pipe, showing different stages of the route. It's a flexible piping, and it's not just very delicate lighting. It has got very important compositional and navigational value as well. It's actually a visual chronology, and the visitor has been moving along it, getting through all the premises. That way, the spectator on the journey, which starts from 1941 and ends at 1945. There are lots of different engineering communications in a longitudinal and cross-sectional lines, but this light thread, this line unites all those communications into a shared and single common structure. This is a unique metaphor of continuity of life and culture during the siege of Leningrad. In our project, we used different types of lighting, general lighting, decorative lighting. In general lighting, we used LEDs of different degree of protection. The project is not finished yet, is at the stage of implementation. So those LED fixtures would be installed in between the communications in the ceiling, and there will be no accent on them. Then decorative lighting, pulling this line. So there's also the upward illumination starts from the floor. It's a flexible lighting fixture with the optics, and it's hidden over aluminum corners, so the visitors would not even see them. It will not attract attention, but it unites the space, mobilizes it, and makes it more cozy, because the topic is very dramatic, very emotional, but we should strike the balance for it to avoid too much of the tragic. So there are 3 layers of light. That way we use low voltage tracks by a laser with spotlights, very small ones, with rather low amount of luminance. This tracking system makes our exhibition very flexible.
So, indeed, we can actually focus the attention of the viewer on a particular artifact. And for example, in the exposition, there is a typewriter. So in spite of bombing at the time of the siege, the museum staff worked. And so we even have a quotation from one of the curators, Petrovsky, who came after the excavations of Urartu here, and he was writing his dissertation paper, and the curator said, now here is a person with the nerves like steel cables, and there's bombing, practically no light, and there he is typing. And so this focus, this particular artifact, they open up a possibility. Now, there are certain things that cannot be described, but there are certain things that can be perceived through emotions. And so light, in certain cases, helps us with emotions, with focusing on emotions. And so we also have an extra focus. There is a niche, for example, dedicated to the sky of the city during the siege, and the blue lamp is used here. These type of valves were used in the house entrances, and that was important to make sure that they would not be noticed by the pilots, by the German pilots. So what I would like to say here is as follows. We really have to think about comprehensive planning and design work. We cannot select one type of light and get decorative lighting and think of the proper effect. Everywhere where there is a conflict between the norms, between the limitations and the quality of perception, we need to approach planning and design work in a comprehensive way. And so sometimes it's necessary to change your view of the object, to see it in a different light. So finally, the light is not just an instrument to illuminate an artifact, but it's an instrument that helps us manage attention and the quality of perception. The quality of the museum light is the quality of our cultural heritage, and our approach to it should not be just technical, but we should regard it as a strategic instrument necessary for the communication within the museum. So that's it. And so when we work on design work next, let's think exactly about the issues we raised. Well, thank you. I shared my opinions, and if there are questions, I'm willing to answer them, or maybe during the break. Thank you. Are there questions to Natalia? Yes, you're welcome. When will we be able to see the exposition? Seems like you told me once that in the Hermitage, time flows differently. So, frankly speaking, it's not something that happens quickly. No, we have been working on that for a long period of time. There is a lot of nuances, but we hope for 2026, 27. I hope that it opens in January next year. Yes, questions? I have a similar question. So the answer is there. So yes, we invested a lot of work into it. And we keep working. Have a large team of engineers, of designers, of art historians, and special engineers who are responsible for the control systems. And the staff of the museum is with us. We hope that you will be able to see it in 2027. Thank you. And our next presentation is the light in the exposition as an element of museum scenography by Irina Kirukhina and Olga Rybkina. Right. Irina Kirukhina, the co-founder of the Metaforma Bureau and curator of the museum projects, and Olga Rybkina, light engineer, a conceptualist of the Yelena company. Good afternoon. I'm Olga Rybkina. I represent Alega company. And today, together with a metaphor more. We will speak about light as a part of the museum scenography. We will just continue our discussion of the light. Now, before the break, before the masterclass, we are not going to speak about scientific research, but we will actually discuss the matters as the creators of the expositions. I was represented as a co-founder of our company. The Planet Ocean is our major work, and it's a very large exposition in Kaliningrad, the Museum of the World Ocean. And within the framework of our presentation, we would like to discuss two things. First of all, what can we do to make sure that curators, designers, that the groups responsible for the expositions treat light as a multifaceted element? Because very often light is perceived by us, by curators, designers, as just a way of backlighting items, although there are many more roles played by light. In our country, in different cities and different regions, new museums are being established, new expositions, where whole teams work, and the teams might incorporate dozens of people. Many companies are involved. And what can we do to make sure that the designers are connected to this work and associated with this work, not at the end of the process, not when nothing can be changed. It's the fact the process is slow. So what can we do for the designers to get involved earlier?
Сегодня экспозиции создаются в очень...
So the expositions are varied, the disciplines are mixed. There are exhibitions and museums where drama is incorporated. Sometimes the concept is designed by a theater director, as it happened in Manege, or sometimes in the Yeltsin Center. So the expositions are very often created in the paradigm of art and science. The Pavlova School in Koltushe is working like that, or some of the pavilions at the exhibition of national economy. But there are lots of different approaches. Different approaches, as I said, numerous and varied. Immersion, interactive exhibitions, and exhibitions based on the architecture of impression. And so these are different approaches and different disciplines. And still, of course, there are new museum expositions which are created on the basis of classical principles. All this diversity requires a special term. And we're using the museum scenography term, the art of creating the speaking, the vocal spaces, a space that, first of all, creates a new environment, rendering narrative, and the disciplines used for the purpose can be varied. A narrative in the museum, that's a key notion. Museum scenography is an idea, a super idea that is translated by the exposition, by all the scenographic solutions, by the sound, by media, and by light. And very briefly, if we speak about the algorithms within it, then we need to understand when the specialists on lighting might get involved. Here you can see the development of the concept, and here is what we're aiming at. The first stage is always the same. We study the initial data. The museum scenography this second stage is very important. Before we talk about the subject, the exposition as such, we need to formulate the key narrative of the exposition. So that's a very important element. When the structure of the exposition is built, then the curator, together with the designer, begins to think about the solutions, about the artistic solutions, and begins to work on the story, on the narrative, going into details, and ideally at this particular moment, not after all the concept issues are resolved, That is the moment when it's necessary to communicate with partners. It's necessary to get the feedback quickly. It is necessary to contact many others in order to get the advice of engineers. The curator and the designer in this case will be able to devise a soluble decision. Let me describe how the work on the project and the lighting of the project works. There are 3 stages: the analysis of information, collection of information, design work on the project, and then implementation, of course. Now, we get a project from the museum. We get from them a general idea of what they want to see, what the vision of the museum is like, what they want to get with the help of light. And then we transform it into the light solutions in order to render the narrative and the story. And we begin to work on the solutions. We test them, we follow the standards, of course. It's but this is a very general sketch, so to speak, for the project. And the museum project, we like to use flexible equipment in order to be able to tune the picture on the site. It's flexible equipment concerning the angles, concerning the color temperature, concerning different fittings that change the light spot. And it's also control, because we're speaking here about the scenography, and control aspects are very important for the proper illumination and for the proper scenarios that take us through the narrative, telling the story. Apart from making calculations using the deluxe and the lux, so we're also making mock-ups, which is not always possible, because very often we're at the site of the project where the project is in place already, and we really have to work on the site. But if it is possible to work with the artifacts before the stage, then we, of course, use mock-ups. One of the important stages is the implementation as such. And here we are consulting the assembly specialists, the electricians, and then at the site, we try to help them with the scenario properly adjusted in order to get the needed result. And then very briefly, without going into all the details, an example of a project. It's a new exposition of a scientific center of the Pushkin Reserve. And so the emotions of nature and the Pushkin type landscape, how the landscape of Mikhailovskaya estate was reflected in the works by Pushkin, and how it inspired many of the creators. It's an attitude, a specific attitude to scenography. We work with emotions, we address the emotions of the visitors, and once the curator formulates this general approach to scenography, the curator gets an idea of the exposition as such, moving not chronologically, but through the lines of Pushkin, through the emotions brought about by Pushkin, finally addressing the emotions of the visitor. And in the process of the work on the concept, we can see the photographs we might get at the end. But well, of course, prior to that, there is a lot of different ideas being born and discussed together with the work group within the museum. In the bureau is so many of the major expositions are created by the external teams, and I think all this is very important. We as a bureau are promoting this idea. All the creators need to move towards those who work on the implementation and the technical aspects. So there should be no conflict in that. All the years of my work, we have been coming across this particular conflict. If you are not familiar with technologies, if you are not familiar with the light and the technical aspects of light, then it's difficult to imagine your solution is going to be that interesting. In this exposition, light is often used as an active player. These are illuminated poetic lines. These are there is also light as a multi-sensory experience in these premises on these premises where the light and the artifacts are working together. These are panoramic projections. There are also fragrances, and the light, along with all these other instruments, needs to work together. It need to be adequate, working together with multimedia, with the scenario as such. And light here changes depending on the time of the year. The time of the year changes within the hall, all the premises, and the fragrances change. Moreover, light can be a full-fledged part of the installation and a major instrument. There is an installation, the fragility of nature. And a visitor gets acquainted with the light image of a tree, and the tree changes. So we interact with this installation, and this is not a traditional screen. And here we would like to pull together different roles played by the light within the exposition. There is a certain problem. Curators, artists, designers sometimes do not really understand well enough that light can have these different functions. So the first thing we have already mentioned, to emphasize or to conceal navigation, movement. So if we take an artifact that is not that valuable, and if we place it at an empty wall with a direct light on it, with everything else dimmed, then a visitor might think that this is the most valuable item in the exhibition. So the art of the museum exposition is based on manipulation. We can manipulate with the perception of the items by the visitors. A visitor might think this is most important as an artifact or a character. So that makes us all very responsible for lots of things. Then a different story. A lot of glare. But the exhibit is extremely important. The passenger just walks by. Then second role, a change space. That's an expo photograph through the range, a change of the color. Just the light color changed and the space changes. And so in green, visitor sees one thing, with red sees something different. And this happens not through multimedia approach, which is quite logical nowadays and which is very often used at the global exhibitions, industrial fora, and so on. And at our projects, in the Belly Dome estate, we also work, and with the colleagues, we work on how to make sure that the space is changed, and not through multimedia, not through projections, but through the change of the light pictures. So the exposition has two scenarios. One is an excursion, the other was a sort of a mysterious nighttime scenario with legends and secrets and mysteries. All this can be achieved with light, and we can create a certain mood. So it can be a feeling, a sensation of discomfort created by light, and curators might think of that to make sure that in this particular location, visitors feel uncomfortable and with too much light. And well, of course, for those who work on the expositions, this work with the light, as well as different media technologies, makes the artifacts and the images live. So this is very often combined with the sound, with the different decorative elements, but the light does play its role here. And of course, light can be an element of interactive media, can be an element of installations. For example, on the left-hand side, you can see the Leningrad Home Guard. So the visitors touch the word in the text illuminated. These words from lines from letters or from diaries, and once they touch this particular letter, the light switches on in the showcase where there is the artifact described by that particular text. It is interactive, that is multimedia, but this is not a traditional touch screen you can come across in many places. That's our work with the light. On the right-hand side, there is another exhibition, the story of the solar energy. The automobiles, the vehicles begin to move through the control of light. And yes, right. And so with these different ways and methods, we are carrying out different narratives. Заканчивают.
Стараясь
So we're trying to, how can we support the project without destroying the magic invested by the creators of the project, and in spite of the iteration within the process, in spite of the fact that we work with documents and standards, it's wonderful to be able to address the specialists and engineers on lighting timely. In order to have feedback, to make sure that the solutions are even more interesting. So I think that it's better if we move towards the development of creative work and technologies, but also towards communication within the team. So here is a journal dedicated, published by us, by our bureau, with the support of EDA. So it's a museum design work in Russia. There are several copies. I left with the organizers of the conference. We have several copies. You can pick them up. And you can also find it on this site. This publication is dedicated to this mutual penetration of different aspects of work, and the work with light is part of that. Thank you.
фактами.
Ирина Ольга,
Thank you very much. Are there any questions? Good afternoon. I am a light designer. Thank you very much for your presentation. Number one, it's the financial side of interaction between your company and the manufacturer. So it's about the settlements, financial settlements, who pays a customer or you. And second question, the ideal picture. You've depicted the design is implemented at the early stage, but in practice, the earlier stage of connection is the more frequently we adjust our work, have to correct it due to the change in input data. How do you structure those interactions? Because there could be some changes due to the reason that some source data have been changed. How does it impact the work of a light designer? Is it an extra service to be paid for separately, or it's part of an agreement or contract? In most part, we and bureaus like that, like us, develop the concept for the museum, and then when the stage of development of different blueprints, feed and pre-feed and feed are being done, different other organizations could be outsourced companies on light or landscape design, rendering other services as well. And from time to time, we keep discussing that with our colleagues so that we should include the concept on light into the general concept of ours. We didn't have it in our practice because museums typically do not have very big budgets for development of the concept. So it takes at least 3 specialists to work for several months. So if we adopt the concept on light and so on, so the budget should be increased. So now it's at a level of some editorials and issues to be resolved, small ones, rather small scale ones, minor ones. So it's all at the level of trust, and curator can make us a call and specify whether this or that thing is implementable. That's the way curator works with multimedia engineers as well. And there are different stages when they start discussing things, going back and forth. Formally, the lighting company gets included into the process when the major developments are being done on paper. Correct me if I'm wrong, but all those blueprints, all those prefeeds were developed all together. Yes, there is one division in it on the light, and the design bureau Metaforma, based on that, is paying for the services of the contractor company. And then there will be the stage of selection of the equipment. The stage of implementation requires another budget specifications with specific equipment and pre-commissioning and fine-tuning during pre-commissioning. Thank you very much. I asked that question because, well, out of our experience, and tomorrow I'll have the presentation how we work with the Museum of Contemporary Tragedy in Kazakhstan, and we worked with acclaimed contemporary work painters, and there could be several iterations of editorials and calling on the phone those painters at the stage when curator only develops the idea. We are in the conference calls and painters are telling about the idea of their work and giving the examples of how their works, their artworks were illuminated in other museums in other countries of the world. Our experience is indicative of the fact that light designers and companies render those services should be outreached at the early stage in the format of editorials and dialogues, and the contract should be signed when you did at least the zoning of the exhibition and finding the optimal scheme. Thank you. Thank you. Thank you very much for your presentation. I have got two announcements. First of all, we have got lunch now. We reconvene here at 2:40. But before that, you'll be met by Nikolai Vorobyov at the entrance to the hall, and he'll show you how it's possible to work with visual space. There will be sort of a masterclass or a workshop, and we'll reconvene at 2:40. You can have
Recording in progress.
dinner.
Давайте еще минуту подождем, сейчас подтянутся. Так, следующий доклад у нас тема звучит таким образом: гибкая система освещения для решения сложных задач музеев. Элеонора Алексеевна Дворецкая, инженер-проектировщик компании Консеру. Или Консеру.
Добрый день, уважаемые коллеги. Меня зовут Элеонора Дворецкова, я представитель компании «Консера». И также хочу сразу отметить, что на данном мероприятии мы являемся дистрибьюторами компании «Эрка», и поэтому хотелось бы немного поговорить про их продукцию в рамках гибкой системы освещения для музеев и как это может...
We should also discuss some tasks which are not conventional and whereby we produce technologies. Museum lighting requires a balance between different solutions, different issues, peculiar attributes of lighting fittings and fixtures. We should comply with the stringent norms, provide for color rendering, color fidelity. So there are different tasks we have to deal with. There are lots of factors we should take into consideration. On the whole, when it comes to museum lighting, primarily, we should cater for high requirements for quality of the lighting. There is a plethora of different factors like pulsation coefficient, homogeneous lighting, fidelity index, color rendering index, regulations, rules, and norms. We should adhere to specific attributes and qualities of lighting fixtures to be proper for installment inside the museums. There are requirements for preservation of the artifacts. This is very important as well. We should take a good look at the illuminance, depending on the type of the artifact. The artifact would be lit up with different intensity. There are highly sensitive objects, so at maximum it should be 50 lux. Less sensitive artifacts, the exposure dose could be higher, and we should look into the color range, color spectrum, no UV, no infrared radiation, and contemporary lighting fixtures could do that. So we adhere to the norms and rules. It's important to mention the yearly exposure. Let's say it's a loan exhibition. We should consider the dose of radiation over the time of exhibition so that nothing bad would happen to the artifact, no color deterioration and so on. The museum has plot a big diversity of different artifacts, sculptures, fabrics, paintings, decorations. They have got different color fidelity, color resistance, color deterioration resistance, and so on. Each and every artifact should be considered on an individual basis. If it's a sculpture, It's important whether it's cylindrical illumination here and the way this artifact would be looked at from the distance to show off its shape, so it would not, and form, should not look flat. As to different decorations and ornaments, all the details, they should look very attractive to the viewer. And next, it's artistic visions and ideas of different representatives engaged in different exhibitions. There are custodians of the museum, of course. They're very important because they make a clear point about the requirements for the artifacts, how different artifacts should be lit up, and we should listen to what curators say. And also, the authors of the exhibition have got their own concepts and desires and willingness and preferences in illumination, and also light designers. They look at everything through the technical prism. It's necessary to strike the balance between all the requirements and requests for a museum lighting, lots of different aspects, lots of different requests and requirements, different ideas, different opinions about those things. It should be well balanced. As to replaceable exhibitions, if it's constant exhibitions, only once you can develop the concept, select the equipment, comply with all the norms and regulations and requirements, and then it will exist like that. But if it's replaceable exhibitions, loan exhibitions, some challenges might come along, because each and every new exhibition is entirely different thing. You should start it all over again. It's a new concept, new topic, new artifacts, new location of those artifacts for us to have a good system of illumination for them without extra resources and to cut costs. It would be good if we have a flexible system of lighting within one hall. When the exhibition is replaced, there is another exhibition which comes along to the same hall. So this lighting fixture system should be adjustable, flexible system of illumination. What do you mean by that? Is some kind of a universal solution for diverse exhibitions and the change of the artifacts. First, lighting fixture should be universal. It should have adjustable parameters like light flux, like temperature, angle of light flux. Everything should be adjusted in a customized way. Different accessories, let's say lenses for changing the light flux, angle, chromatic filters, different options for installations. The other day it was mentioned that it's not always reasonable to place the lighting fixture under the ceiling. Sometimes you should have upwards illumination. It would be good if our lighting fixture could be installed in different places and centralized control intelligent system so that all the lighting fixtures could be readjusted for a new system of illumination. What's the beauty of such a system? It's customized setting. Each lighting fixture could be adjusted for a specific artifact to identify different color, temperature, the angle of light flux, and so on. And such a system, when the exhibition is changing, it could be readjustable on the basis of the same equipment. We can readjust the system of illumination to install some accessorizers which would be necessary. That way we cut costs. We don't have to buy a new equipment to illuminate a new exhibition. We can use what we had and used to have, but to readjust them and to have no parameters on it. Further on, Our company recently encountered the big number of requests for museum lighting, and we decided to research the market, what our peers are doing in the same market. We made market research, analysis, flexible systems, what ERCA can offer versus other peers offers on similar items. We did market analysis, and there is a comparison with different parameters, focusing readjustment of the angles and ERCA versus other manufacturers. ERCA can satisfy all the needs of the customer for this system. And it's all done on the basis of one of the same lighting fixture model. Nothing extra is to be acquired by you. You don't have to buy other lighting fixtures. As to what our peers are doing, other manufacturers, other factories, they're doing well as well. But our market research showcases the fact that other options could not be used on the basis of the same one and the same lighting fixture. So there should be other options or something like that. So ERCA is in a winning situation versus its competitors. ERCA has got lots of lines of lighting fixtures, and all those options are available for those lines of lighting fixtures. In what way ERCA company on the whole accomplishes such wonderful results? Why do they can offer all those options to the customer? First of all, high quality of ERCA products is because it's a full control of the entire production cycle since the moment of the idea, when the idea is pitched, all the way down to manufacturing. ERCA manufactures its own lenses, its in-house development, in-house production, manufacturing of those lenses. So it's all done on the grounds of the company, and then it's manufactured and offered to the market. And also, you are very exact about the requirements, the temperature of the light.
нас вот есть пол.
Let's assume we have a set of everything we need for the exhibition. So we have the exhibition halls, we have the new exposition, the exposition changes, and we have the needed system of lighting, which will help us make the proper lighting in the new space. So what do we do in this case? First of all, we analyze the exhibits, so we define the light sensitivity. We understand better how we can illuminate them. The concept is worked out for this particular exhibition, and then we put up the light fixtures. Thanks to the centralized system, we can do that, and with all the necessary accessories. With this, and then the testing of the stage in order to understand what we have in the end and what we have after all the manipulations. If something goes wrong, we have a chance to correct everything, to change the outlay. So then we use the same type of light fixtures that we already have been using. So here is a case of ERCO fixtures being used in different countries of the world and in different museums. As you can see, the ERCO light fixtures are being used successfully, look beautiful, the exhibitions are most popular, and they deserve special attention. Well, that's it. That was my presentation. Thank you. And now your questions, if there are any. Eleonora, thank you very much. Once again, thank you for the ERCO presentation. I'm quite sure that many are familiar with the ERCO company. I have a question as follows. As far as I know, ERCO is not registering projects any longer in Russia. How can we buy their equipment. What can I do as a designer of the company, buy and sell the ERCO products? Yes, look, I'm an engineer and designer, and I'm not involved in these matters, but here with me there are Renata and Pavel, who are involved in these processes, so you can ask them, and they will give you detailed information. This was a rhetoric question. The ERCO officially does not supply equipment to the Russian Federation territory. Only, and if we register a project that is theoretically in a different country, you can discuss that. There are always solutions available for it. Thank you very much. Thank you. Right. Marina Vasilyeva, our next speaker, she will speak about the length of service of the light fixtures. She is the head of the representatives of Desano Illuminazio, an Italian company. Good afternoon. I am Marina Vasilyeva, and the head of the real representative office of the Italian factory, which has been working in Russia since 2008. The factory itself is in Italy, but registers and provides equipment to Russia. It continues working with Russia, so I can say that not everything is as bad as it might seem to be. So when the question was raised about my taking part in the conference, then since I have not been working with the museum light in Russia, the colleagues said that they have been working with cultural heritage in Italy a lot, and they work with different museums and galleries. So in my presentation, I used pictures of the real sites and monuments, as the topic is not just advertising. The length of service of light fixtures is a topic for discussion. Everything is difficult in this particular theme. Mutual understanding between suppliers and customers, difficult to assess the results. So let's talk about all these matters. So there is a lot of different themes related to the use of light engineering devices, and in different standards, they are quite well reflected. We know what we're talking about, but there is a parameter that is not mentioned anywhere. Let me show an example to you. Let's begin with the following. Everything operates with the warranty, and according to civil code, it's established by the producer or supplier period of time. And if we take the judicial practice, it's a period of the needed for the simplest solution of different problems. That's when the customer can appeal to producers or suppliers. So there is a term of service of the LEDs. We know that LEDs are gradually degrade. And let's have a look at the following. I found only two standards where this information is mentioned. One of these concerns museums, and that's quite a good thing, because most probably the conference and people who are involved in the process are really realizing the irresponsibility. So in this standard 58, so the length of service is years, and so it's the period of time that covers the repair works as well. There is also information that says that it's not the term of the resource of the light fixture itself, but it's clear and not clear at all. How can we apply all this, particularly in contracts? And moreover, not everyone understands that the warranty and the length of service are not the same. This is something to be discussed. Some things seem to be simple, but they're not that simple at all. So I hope that people who are far away, so to speak, who are watching online what is happening here, do not always understand when they are asked to sign a contract concerning the 2-year guarantee, what that might lead to. So it's all very simple. Here is the list of some standards within which you will find information concerning the process of work at the market, what can be requested, what should not be requested. Abroad, things are quite simple. In Europe, in particular, there are 2 parameters: LM80, LNX. LN80, it's a so-called recommendations of the American Light Engineering Association, developed in the year 2008. They range LEDs by the life duration through the temperature regimen. And this concerns just the components. It appears that when you deal with a very good light fixture to 99%, you will find an LND which was ranged following that particular standard. But if you take a good LN80 and put it into just a regular and ordinary light fixture, it's not going to work over a long period of time, because there is a process of the creation of the body involved, of all the materials involved in the process of the fixture, of the circulation of the driver, and lots and lots of other things. So it can be a very good light fixture, but it can also be an ugly device not working at all. So what do they do in Europe? They have a standard at an Plus, which it's a very expensive way of certification, but it makes it possible to understand what particular temperature mode is needed for is associated with a particular light fixture. We don't have this standard. Our light fixtures are not certified like that at all. So now, here are the stages of the service of the light fixtures. In one of the previous presentations, it was said that the supply of light fixtures is the result. No, it's not a result. It's just the beginning of a very long road. And for example, there are 3 light fixtures. 2 work very well, but one is not on. Well, we can change the driver and it begins to work. Now it seems to be all right. That's what the situation is like. Then, after a certain period of time, those some light fixtures might degrade. Now, we were able to see in this state standard some parameters, but none of them define the degradation of the light fixtures. It's our sensation. It seems to us that there is not enough light as related to what? We don't know. It's difficult to define that properly. So what else happens here? Quite often it happens at the time that is very close to the guarantee period. So I mentioned 2 of those light fixtures. One works perfectly well, the other one degrades. So they are within that period of time. But the 3rd one, which also degraded, is outside the term. So the customer who pays money, who lives through a certain life with that particular light design, with engineers, with designers, and this might be a very long road. After a short period of time, relatively short period of time happens. So we all understand, working in the museum, what a long period is like. 5 years is never long. So this process occurs, and there we are, and the customer is left alone with that problem. The customer has no way at all to appeal against what is happening. And the designer is not always guilty of what is happening. As we can have a look at what is happening next. So there is a certain, how to put it, the interests seem to be disintegrating and diversing. And so over this period of time, one light fixture, according to Alan, degraded by 80%. worked for 100 hours, and the other two are already part of the waste that cannot be even processed. So that is every single phase of any LED light fixture, whether it is one for the museum or somewhere for general lighting. But it's always like that. So when we look at the situation in a reverse way, then it looks somewhat different. Now, here is the parameters of the selection of light fixtures. Some prefer technical parameters, others rely on the reliability of partners because they were well-known companies with very good reputation. And so we sometimes do that, and sometimes the cost, the price, the terms, and the time of the delivery needed for that. So usually these are organizations that are responsible for assembly work and who want to earn money as quickly as possible when mounting the light fixtures. I would divide light fixtures like that into three groups in order to see that the final user understands what they're buying. Because a designer can plan light fixtures of the green group, but in the process of acquisition, a red group was suggested, and it's not the problem of the designer at all. The designer has a project, but everything degrades with time, and there's no need to apologize to everyone because there is no properly integrated process. Someone makes a decision in the process. There are some matters that are not properly coordinated. Something has not been delivered, and here's the result. And who suffers? The customer, the user, the visitor of the museum suffers as a result. And so we can't do anything about that because the next open for funding is open after 5 years. And nobody knows what to do about that. Since I can appeal only to my light fixtures, I can demonstrate one page to you. I think every European light fixture has a similar appearance, and there is a clear-cut power factor described here. 100,000 hours of work, and here are the parameters of degradation that are all described here. These documents are not printed just as paper, though. These are offers, and so we're responsible for that. If we say that there are 10% of degradation by the end of the time of life of this light fixture, that's exactly what is going to happen. There is a lot of competition in Europe, just like here. There are Chinese manufacturers, and so all these parameters, the length of this, they are proving that the light fixture is of high quality. There are tripartite contracts nowadays signed where not the guarantee is listed, but the duration of the period of time over which the light fixture is going to work. And that's what all the companies are moving towards to. Those companies that are believed to be themselves of high quality. All the other type of equipment is not project equipment unless there is a guarantee or a warranty like that on that particular item. There is a French library, and you can see these light fixtures look like that in there. There is something else I would like to demonstrate from the point of view of choice, money. So we take a certain period of time over which the light fixture is going to work. Let's take one here. How many hours? 3,000 or 8,000 hours, depends on the intensity. If there is just a 5-year warranty and nothing else, 50 million.
So it's 40 or 50 million for 5 years. That's the money you spend. Nothing else is promised to you. If you're promised more and it's recorded in a document, you may divide it into a number of years, for which this lighting fixture can work in accordance with the warranty. 30,000 or 50,000 hours. But if it's, let's say, long exhibition, it's one thing. If it's general illumination in corridors and passages, the Hermitage lighting up certain fixtures. There are different requirements, but fixtures can work there. And I was told that lighting fixtures are also installed at International Space Station as well. So real artifacts we're making in Italy. I represent a factory, so I work in the format of supplies of equipment. We can do a lot on our own account as well. And I invite you to discuss the life cycle of lighting fixtures so that those rules could be promoted in Russia as well, so we could work with the projects in a more civilized way. So to put it down, it will be less politics and more understanding why we have to pay this, that. Thank you very much. That's it. Are there any questions? I have one, if you allow me. As to full life cycle of the device contract, do you have a background of that? A background of the European projects, wherever? How is it regulated? There are some fixtures working for more than 15 years. In Moscow, there are certain fixtures working since 2013. In Moscow, they are still functioning, even if the drivers are out of order and all. But the component base has been changing day in, day out. And they say that some lighting fixture could be manufactured within 2 months. My colleague would have said, no, we wouldn't do that. No way, because we should test the equipment, test all the components. It takes a lot of time. 4 or 5 months, maybe, mindful of the project, when we really select the right components. As to signing agreements, confirming the certain deterioration of the lighting fixture, which will happen in distant future. That means that they know how to manufacture such kind of a lighting fixture, which could work for a long time. It should not be very high intensity, very high capacity. There are lots of parameters which would be very good for LEDs to work for very long time in lighting fixtures. We're talking about devices, but I am talking from the standpoint of the user life cycle, robustness, deterioration, depreciation of resource. How does it happen and how long does it take in practice? Here in Russia, for that, first of all, regulatory base should be developed and taken on board, which is none of the case. At the light technical conference, all those issues are raised, but the regulatory framework is not there. In Russian, we don't know how to implement it all within the Russian legislation frameworks. Thank you. Just hold it, stay on. There are questions. Yes, there is no legislation about it in Russia yet. As to EU legislation, how does it look like in practice? How do they measure the degradation and deterioration? I, as a designer who's going to implement a project, let's say we started implementation, we should measure illumination without the impact of daylight. So once yearly, a customer or a certified laboratory should measure that illumination under the same conditions and will see the changes in the light flux from one or a group of light fixtures. And then at some point we'll figure out that that lighting fixture reached that level of light flux which is considered as the very end of the life cycle, or does it look differently? Well, for example, lighting fixtures and fittings, how do they work when norms and rules are there? Once yearly, they do the testing of the object. It's a good practice. If you do the measurements periodically, you'll see the difference and the real degradation of lighting fixtures. I said at the outset that I don't have any recipe as how it should be done right. I just know that the absence of legislative framework and protection of lack of the system of protection of consumer from some inferior equipment. The absence of that is bad. It should be there. It all could be done in a tripartite agreement between manufacturer, consumer, and supplier within one agreement. If it's in the format of measurements periodically done, it's a good practice. In practice, I haven't heard of any case of that kind in Europe as well. Well, regulatory requirements have been changing about life cycle and so on, because apart from L parameter, they introduced P parameter, the changes in light fluxes, the drop of light fluxes, and to say at which moment of time lighting fixture has stopped exercising its function. In practice, it's not possible to say, but if we do measurements periodically, we'll see the changes. That is more consistent. To recap on what you said in your presentation, it's a very good presentation, but I think that we should move this way, doing periodical measurements is good for control. I agree, the problem is out there for us. The problem in the Russian market is the following. Previously, the life cycle of a lighting fixture in line with the warranty used to be 5 years, now is 3 or even 2 years in the warranty. That's the problem. What else could happen over those couple of years? Nobody knows. I think that we should have the norms about the lighting fixture degradation with time. Thank you very much. I agree fully. But of course, law enforcement practice should also be there. That's another avenue for us to pursue. Let's say for ships, for vessels, even after the life cycle of lighting fixtures is over, according to the warranty, they cannot apply just the articles of civil code. They should be relying upon GOST, that is state standards and rules. So we discussed those issues related to lighting fixtures. Sometimes it goes for several years. All those suits, if there is a lawsuit, the situation is not altogether simple. So I'm here to say that the more we put things in order along those lines, the more clear it's going to be to a consumer what they do they get for what they pay for, or maybe to pay less, but then they should be aware that this lighting fixture would not last as long as more expensive ones. Maybe it's all about servicing sphere. Manufacturer selling equipment could offer another service like maintenance service in the period of the warranty and post-warranty period, let's say. In 2012, 2013, there were lots of very popular fully and entirely LED projects, which were there. Even if the equipment is high quality, it's another couple of years and it'll deteriorate, it will stop functioning normally. What comes next? Post-warranty maintenance, nobody is doing that. That niche is not occupied yet. I think it's utterly pointless just to come along with post-warranty maintenance 15 or 20 years after the life cycle, just after the life cycle is over. There should be some robustness about this lighting fixture, but if something happens within the warranty period, that's another thing. But I think it's rather judgmental. Maybe we'll continue those discussions later on. Thank you for your attention. Thank you. Next presentation. Natalia Potapova, director of the Museum Agni Moskvy, Lights of Moscow, about the light in the museum in simple words, 22 rules. And to recap on the previous discussion, I could tell you that at the Hermitage now, there are requirements to be introduced about changeable and adjustable source of light to come along with the lighting fixtures because it's degrading, and some of the manufacturers are manufacturing exactly that type of lighting fixtures for us. Dear colleagues, good afternoon. I'm glad to be here at the fourth conference of the Museum. I am present here, and my presentation is going to be rather brief. Being in this hall and the other day listening to the presentations, I become aware that this lighting in the museum conference is a high-token event when professionals come together. They're well-versed in this topic. It's very easy for them to grasp all that information. But as a representative of a small museum, I think about small and tiny museums, which is a plethora in our country. The other day, lots of fancy pictures and beautiful projects were demonstrated. There are lots of different types of museums in different regions of our country, and we should take a look the way they are illuminated. Sometimes this museum space is just lit up by old and obsolete luminescent lights, all types of filament lights. That's the way the picture gallery looks like. That's the way of illumination. There are lots of museums illuminated like that in the provinces of Russia. Such museums cannot afford having all those lighting fixtures and to employ specialists. The situation has been changing and more funds are extended for creation of museum exhibitions. Certain things have been changing. This is a new hall in the same museum. The situation has changed, but not radically, not for better, I think. This is entirely new exhibition. That's the way those new exhibitions are looking like in some of the museums. open light sources, nobody is thinking about color temperature or fidelity index or color rendering index and so on. So it's entirely new exhibition you can see here and quite expensive, by the way. So it was rather expensive. It's a small hall. So I have a question. Why do those lighting fixtures are just blinding the eyes of visitors and so on? I thought maybe it looks like a snow plane and there is a blazing light here. White snow is giving off, and so there should be financing enough for the project for editorials and consultations before embarking upon the project. That is why thinking about my colleagues and other museums, there is a wonderful book, Light in the Museum, and I decided to write sort of a guidebook for my colleagues as well. But of course, the Hermitage was ahead of me, and when I read through that book, I figured out that the same many museum workers will not understand this because we are in different spheres of museum activities, not each and every museum worker is ready and willing to read through and to learn. But we do need people who really care, and that would change the situation. This is the guidebook. First, it was made electronically, and now it's a printed matter. It tells out like hot pie, hot cakes. We received it last Sunday before I boarded the train. In the previous conference, we had postcards, 10 rules. Now we've got 22 rules. Yeah, so, like we call them the 22 rules uh, compiled by different objects, so all museums. This book is written just as though different museum items were in on exhibition in the other city, but nobody saw them. So all those artifacts decided to write those rules. It's rather humoristic and written jokingly, of course. But that is also important to come along with those rules. The first rule is very straightforward. It's like the popular done words, and it's good that there are some rules which were developed before in the book. Those norms are contained, the norms to be used by museum workers. Sometimes they forget about the yearly light exposure for objects.
Good. It's all clear cut, as if for the first year graders. So, what is Panova? Nobody will know what that is. Here in that particular room, they understand that is a particular type of a skirt. But some other people from the museum might know. But if we ask other people what the index of light transfer is, there will be only two persons who know what it's all about, others do not. So we would like to put these stories together. This is the story of the naturality of the even lighting and the index of the color transfer, so that every detail is properly visible. And here is the color temperature and how to choose it, pulsation, and here is the rule that is for calculation. The very important for the acquisition of different types of equipment. In one of the museums, there was a big canvas, and colleagues were able to find 18. Well, actually, they thought there were to be 18 light fixtures, but actually, it was possible to select something much less expensive. And then there were other colleagues who had a project, and the calculations were ready, but the equipment was not exactly for the museums. And they said, okay, we do not have money for something of better quality. But you will have enough money if you buy the correct type of equipment with extra features. Then it all continued. They said, no, we still did not have enough light fixtures. And then next day, I asked for extra photographs. Everything was simply
время они сказали, что
wrongly distributed. So they actually told me that there was some extra light fixtures. Here was glare, blinding effect, and the story of a small thumbnail, and which wants to have its own ray of light and channel lighting. I was in a new museum with a new exposition, and the showcases are not that poorly organized, but there is, generally speaking, rather poor lighting. The colleagues said we cannot do anything about that. It's all arranged in such a way that we cannot dim the light. We can switch off the light, and then the visitors will be up there in absolute darkness. But that's so all these stories prove that there is not enough thinking put into that. These are the contrasts, the expositions. We do not know how correct it is. Then the background and how bright it should be, the sources of light, because even now we come across stories when in one chandelier there are different types of bulbs, and the projection equipment and the controlling systems. So it's that's a complex system. So it's not always quite clear who is going to maintain this equipment, and what will happen later when you set a certain system of monitoring and control. So what we do at the stage when the project is being drafted, and here we are from the ancient portfolio, which tells us of that it's necessary to know more about the company portfolio, because many companies offer their services to the museums, but we're not a state museum. I never took part in the tenders, but we know from the colleagues that usually the one who offers a cheaper version wins, but the quality suffers very often. So we need to be very careful here to make sure that we do not deal with the fraudsters. Rule 20, it's about the features. The museum staff find it very difficult to describe all the characteristics when they take part in all sorts of competitions and tenders. So that's it's an open matter. Who can help us with that? And Lyubov Evgenievna recommended, first of all, we need to address colleagues who have gone through that particular project, a similar project, and that's about us. We very often forget the maintenance aspect, and after talking to museums, I can tell you that many believe that they take the light fixtures separately from the museum as such, and they ask them if there is a dimmer on this light fixture. They wouldn't even answer this question because they are hardly ever familiar with the characteristics of that light fixture and how to tune them. And the last and very important rule, already mentioned, what can we do to make sure that at the stage of design work, the light is not forgotten? So there we are. It's very important element. We need those special drops to have to sustain our memory, because when you work on the museum exposition, you should never forget light to avoid serious technical problems at a later stage. We know that light is an enormous potential. There are wonderful Soviet expositions, museum expositions prepared, and I look at them and I can see that we don't feel like changing anything there. It's not outdated at all. We just replace some of the light fixtures there, and it will get a new life. And we had a project like that. We helped our friends from the Buzuluk, the Museum of Local Law, so what does the story end with? It happens there is money for equipment, but there is no money for consultancy and for the project. And you need to do something, and we help our colleagues as much as we can. And there are other stories when we just talk to them on the phone on where to place the light fixture, what kind of the bus line to use. And so that's how we communicate sometimes, and we help each other. And the book is published to assist all of us. I brought quite a lot of copies, and so I'm happy to leave it with you. I don't think there will be enough copies for everyone present here, but I will definitely be happy to leave it with those who are interested enough. So we published it with our own funds, and the circulation is quite high. So if you need a copy, come to us. We'll be happy to help you with that. Thank you very much. Thank you. Thank you. That's wonderful. Yes, and these two books supplement each other. Yours is very creative and could a very good illustration. Thank you very much. Questions to Natalia? Thank you, Natalia. Thank you very much. Thank you. It's an important contribution. It will be interesting to read and comment on the book. But now I have a comment, and I really wanted to voice it a bit earlier when there were other speakers making their presentations. Let me do it now. There's a lot being said about the destructive impact, and for some reason, there are only two parameters mentioned, light and the time of exposition. But there is another very important parameter, spectral composition, because the warm and cold light with different illumination, different exposition, have very different destructive ability. And I can see this either a separate rule that should be added, or in the recommendations that we have on the assessment of destructive effect. We need to mention that cold and warm light have different destructive effect. Yes, now the rules can be supplemented. There are many more rules than 22, but the book is first of all for our colleagues who are very far away from light engineering, and it's important. It is important for them so that they understand what needs to be done. Sometimes I can see that the exhibit is next to the window, and the side that is turned to the window has 7,000 lux, not 50 or 100. Very different stories are there. That's our reality. The reality we should never forget. And I forget to say that the book is illustrated by Konstantin Karmakov, a very good artist, and we would like to thank Svetlana Lebetkova, with whom we have been working at length, and Ksenia Lanikina. This time she is not with us here, but she also pays a lot of attention to the museum lighting. Let me add that at each conference, if there is one book published for each of the conferences, that's going to be quite a collection already. And so, there's some advertising of the light engineering. of the institute that has already special courses dedicated to that. Sergey asked a question, and probably allow me to introduce Viktor Dorokhov, our next speaker, head of the Laboratory of the Climate of the Museums of the Monuments of Architecture, Gosnir. The conservation of monumental painting when creating artificial lighting in a museum architectural monument. Good afternoon, colleagues. Our laboratory deals with numerous aspects of the museum climate, mostly temperature and humidity, and light, of course, yes. Lately, we began to work with that. And actually, now in the year 2001, one of the first standards on museum lighting was drafted with the involvement of our professionals. So yes, we need to deal with different processes that are so important for preservation and conservation. And while for the museums, the monitoring and control of temperature and humidity and attempts to control those are almost 200 years old in the Hermitage and the Russian Museum since the middle of the 19th century. For the monuments of architecture, the situation is very different, and it's much more difficult. And over a long period of time, this standard, there was known a following standard: museums and monuments. That's our heritage, and the rules of conservation and preservation are almost the same. So with the 20th century and the 21st century, when the natural science representatives began to work in the field, it became clear that the requirements for the architectural monuments preservation are quite different, and quite different from those that are required for museum artifacts. So not that long ago, we came across a situation when, no, I'm not going to mention the specific sites, because we are very often invited as medical doctors to treat a disease, and we don't speak about the patients ever. So cathedrals, within there is a lot of museum artifacts, and let's say there is some flooding of the cathedral, and it was impossible to get inside several months every year. So the question was, could we make sure that the cathedral is used for the museum purposes year-round? And there are air conditioning systems that ensure the parameters of the museum, 18, 20 degrees and 55 degrees humidity. So everything seems to be very simple, but what it ends with, the windows were not changed at all. There was no analysis of thermal protection made. And over the first winter, on the windows and on the murals, the windows were rolled, and there was 55% humidity inside. So they were iced, and those windows, and with thawing, well, of course, that ice melted and damaged the murals. So that was a very severe damage. What kind of protection can we speak about? So the scientific approach in the field of the architectural monuments, that's a different story. In different countries, you will find different methods and different types of research work dedicated to this. If you, well, generally speaking, all the progressive trends are prescribed by different international institutes. A very good example is the UNESCO Convention on the Natural and Cultural Heritage Protection of 1972, supported by different international organizations, by COMOS and CROM and many others. And so this convention stipulates special measures taken for the protection of particularly valuable monuments of architecture, including different types of research work carried out and monitoring organized at the sites. So here I tried to present to you the interconnection between different elements of that monitoring over the conditions necessary for protection, for preservation. And these are elements of the maintenance of the monuments. There's the fourth paragraph of the Venetian Charter. So this control over the maintenance is actually the care that we take over the monuments. In order to take preventive measures, we really need to know what the current status of the monument is. Status and state. And in our report, we look at different aspects of conservation and preservation of the murals, the monumental paintings. And for many of these architectural monuments, they are the most important decorative elements. And of course, we relate that to the lighting fixtures. Both of the monuments we look at are cultural heritage sites protected by UNESCO. So there is another thing associated with monumental painting. The curators believe that the major destructive factors are temperature and humidity. So it is really believed that murals, particularly frescoes, with mineral components, because mineral components are part of the wall covering, are very sustainable to light. And so there's no need to work on the light and lighting. But over hundreds of years of these murals, these murals had been repainted many times, and this happened before they were recognized as monuments, and there were many restorations carried out. And the materials that were used for the restoration of murals are practically never examined from the point of view of their light resistance. And it appears that after restoration, there is very quick degradation occurring at these sites. So I also need to say that the impact of light and its interaction with monumental paintings, with murals, is very often synergetic. So that means when humidity goes up, the impact of light gets stronger. So the excited site of moleculars plus humidity lead to stronger chemical reactions within. So that's what happens. Apart from the impact of the ultraviolet radiation, well, of course, there are different pigments might have a serious impact on the condition in which the minerals are. Now, for example, the peeling of the frescoes totally restored occurs if there is a light fixture located close enough to it. So here is a fresco on the white walls, and here in this particular site, there are just a few fragments left like that, because most of the painting disappeared in the 19th century when the authorities decided to paint this church anew. So it didn't work that way for some reasons, but anyway, some valuable fragments have been preserved. Fragments of the 12th century painting, but they are very limited in size and in number. Very small fragments there are left there.
Значит,
At one For the cycle, we do the more monitoring, irrespective of the mode of use. We use thermal visor and we obtain temperature abnormality close to the site of the painting which were related to lighting fixture. This is not the best picture here, maybe, but nonetheless, that's what we have here. These pictures, there are three different kind of views here, and the different angles and close-ups. We can see more. Sometimes it's rather difficult to select the right angle of imaging when you take pictures in the zone of the action of the lighting fixture. We can see certain parts of the painting when restoration was finalized 2 years ago, and you can see that the results are very expensive restoration, yet were not the best ones in this particular case. Because of the wrong selection of the wrong type of a lighting fixture for this particular artifact. And this is the adjacent vault. You can see the juxtaposition of the lighting fixture. So the those remaining parts of the painting are lit by a specular light here. Lighting fixtures are hitting the white stone here. And then that was bleached. So this reflection is comfortable and it's safe when it lights up these remnants of painting on the walls. The point of lighting and illumination could be changed and the situation would be different. Next example. That is this piece of a vault as well. The temple painting on 17th century tempered technique, periodicity is 15-20 years. And this room has been functioning for 7, 8, 9 months every year for the groups of visitors for excursions. And you can see there is one lighting fixture on this cornice, and via the window slots you can see the small light, but so it's just a combination of illumination. There are other places, other spots of this gallery, and you can see other lighting fixtures. And we were looking at different modes of conservation. We were experimenting with different temperature. We were making pictures by thermal visor along with different time periods. So the heating of money sites with on the protruding parts, not just on the protruding, but on the concave parts as well. There is the heat up to 22, and We made special terms of references for restorative painters who survey all the paintings here, and we already obtained the result that near the lighting fixtures, there are some sites which are degraded more because of those lighting fixtures. When we work with lighting up different artifacts, it's important for us to consider it for different types of artifacts and for murals and extramurals. And there are broad opportunities related to LEDs. It's good for energy efficiency and for mitigation of adverse impacts of thermal factor. I think that in most part, all of you are aware of the advantages of using LEDs under for illumination of extramurals. Just its flexibility, its easy control, which is done. It's very convenient to create interactive modes for the illumination, which is very good for real museum practice and for exhibitions and lawn exhibitions. So it's possible to create interactive modes in this control of illumination degree, and that way we can cut costs for electrical power supply because there are less zones and spots needing extra illumination. This is very important for museums of different levels, for regional and municipal levels as well. Well, they're trying to be as energy efficient as possible, especially for those museums which contain just treasures which are inscribed into UNESCO heritage sites. Talking about museums, I mentioned the monuments of architecture as well and extramurals. Thank you very much. There is a question. Thank you very much for your presentation. The map you're demonstrating this remaining part of heat and its impact, whereby the heat was higher, the pigments look lighter. No, it's related to the geometry. The volts are converging just like that. And there is this heating point whereby the volts are converging very close to lighting fixture. And there was one slide showing the volt, and there should be a thermal map if you show us that slide. This is the gallery protruding west-east, from west to east. It's all painted. It goes eastwards, and in the adjacent wall, at the adjacent wall, there are 4 or 5 lighting fixtures. And we are accustomed, and that was mentioned in the presentations, that to the idea that there is a cumulative effect of color and color temperature. Very important, this cyclicity, periodicity. There is a tour of visitors, then you turn off the lights, it cools off. Another tour turn on the light. So unlike cumulative effect, this will be on and off. And that is also the degradation factor, destroying the artifact. Thank you very much for your presentation. As to light impact upon thermal map, we oftentimes give it a thought when we're calculating destroying impact for artifacts and or doing designs without calculations on limited illumination. This methodology is not up to 100% right because it doesn't take account of the fact that artifacts could be dark and under the same illumination, they would absorb more light than they reflected, which should be shown in the methodology. That's theoretical, like rule of thumb, but from the experience, if you see that darker parts of murals are degrading faster than the light ones. No, we didn't make this conclusion at all. And the definition or connotation of the dark and light for human eye and for different fixtures is different. For a painting, just an example, when those halos just are painted in a way that there are some metals introduced to the pigments. We do the positioning, imaging, and we see those pigments in the halos, different reflections, different radiation. Thermal visors are good, but they have got their error margins, of course. But what for human eye is dark or light, it doesn't work when we use specified equipment and thermal visors. They see it differently. Thank you very much. Sort of stock taking. Because we're finishing up here, then there will be tours around the repository. I would like to extend my heartfelt thanks to all the attendees and all the speakers for very interesting and very useful presentations. Your points were very insightful and came in very handy for all the attendees. And by the end of the day, tomorrow as well, we'll have the tours and we'll have the meeting in the middle of the day tomorrow as well, one of the discussions. And tomorrow we'll also start at 11. Thank you all. Dear colleagues, we're going to have two tours. One is a technical tour. Those who are booked up for this technical tour, I just get to the registration desk next to the check room. And then you'll be divided into several groups and you'll be shown engineering systems of the repository, those up on the road, excursion around on the routes of open storage of the stocks of the repository. There are tour guides for that. Tomorrow there will be similar tours, so you can shift those tours. You'll see both within those 2 days, today and tomorrow. Thank you all.